Hello and welcome to Math World. Today's lesson is about irrational numbers. So we're just simply classifying numbers today as irrational or rational. To take a step back and think about classifying numbers, remember that we know whole numbers to be numbers like 0, 1, 2, 3. There's numbers that you first learned to count with. And then in sixth grade, you learned about integers, which included negative numbers, such as -5 or -1000. These are numbers below 0. And then in seventh grade, we focused on rational numbers. And that included all the numbers between 1 and 2, like 1.5 or 1 3/4, or 1.75. The rational numbers included all those fractions and decimal numbers, both positive and negative. So there's your sixth and seventh grade math. Well, in eighth grade math, we're adding a new type of number called irrational numbers. Irrational numbers are any numbers that are not rational. Another way to think about irrational numbers are numbers that cannot be written as a fraction. You cannot write them in the form of a or b, which means a fraction. So that's the simplest definition. Let's look at those definitions and some examples. So again, a rational number are all those numbers that you've learned already that can be written as a fraction. This includes all those whole numbers that you learned, all the integers with the negative numbers. It includes any fractions. It also includes terminating decimals. That would be a decimal that ends, such as maybe 0.75. And it includes repeating decimals. So decimals that go on forever, like 0.3 repeated. We know that 0.3 repeated is really just 1/3. And since that repeating number can be written as a fraction, it falls in line with rational numbers. And lastly, since we have been learning about square roots, perfect squares are rational. Because remember, perfect squares, such as the square root of 36, has a whole number answer, making it a rational number. So there are our rational numbers. Let's go ahead and separate these examples from our irrational numbers. Now, irrational numbers are any numbers that cannot be written as a fraction. This includes those non-perfect squares. Remember, a non-perfect square is a number that's not a whole number, like maybe the square root of 7. If you type that in your calculator, you'll get some crazy answer like 2.8545, bunch of numbers that go on forever and have no pattern or do not repeat. So non-perfect squares are irrational. Any number, in fact, that goes on forever and doesn't repeat is irrational. Any decimal that is non-terminating, non-repeating will be irrational because you have no idea what the next number in the decimal sequence is. That makes it irrational. The most famous of these irrational numbers is pi. This is pi right here, or its symbol, pi. And pi looks like this, and it's estimated to be equal to 3.14, and then it does not repeat those numbers. It has different numbers, and it goes on forever, making it a non-terminating, non-repeating decimal and the most famous irrational number. So in this lesson, we're simply looking at numbers and classifying them as rational or irrational. In class, we took a few examples and we classified them. Pi, of course, we just said was irrational. Well, numbers like -17 are integers, they'll be rational. We know decimals that end, like 3.275, are rational because they have an ending, they terminate. Whereas decimals that go on forever, like this one, 0.04053661, dot, 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 you see the dot, 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 that means it goes on forever. that one is going to be irrational because it goes on forever and it has no repeating numbers in it. Now, if it is repeating, like 0.76 with the repeating bar above it, the repeating bar is rational, we said. So 0.76 repeated would be rational. And the last one, this one here, 3.5655655556, it may seem like it's repeated, but these numbers are not repeating. 56 is not the same as 5556. So this is not repeating. And since it's not repeating, and it has the ... telling us that's going on forever, that's going to drop it down here in the irrational section. We would classify this number as irrational. So there's your rationals versus irrationals, just a new way to classify these new crazy numbers. Well, that's it, and I'll see you in class.